If we look at this differential equation here, we notice this is not equal to 0 on the right-hand side, so it's a non-homogeneous differential equation. And we'll explain through context how this is a method of undetermined coefficients. You'll see that how it pops out in a second and why that name makes sense. For now, though, let's use our intuition. Let's not proceduralize too much. Just ask yourself, well, what does y have to have in it if the right-hand side is going to have an e to the 2t? Well, if I look at this, I could have y better have some e to the 2t's in it, because otherwise they're not going to equal each other. But some of the y might cancel out with the y prime and the y double prime. These things might self-eliminate somehow, but at the end of the day it has to equal e to the 2t, some multiple of that. Well, the only thing that's going to make sense there is if y is based on e to the 2t. If we don't have that there, there's no way we're going to get one on the right-hand side as well. Now, is that going to be generic enough? Not quite, because you notice this is a 3. And if I had y equals 3e to the 2t, I'd have to have 3e to the 2t's here as well. But we also have the derivative, second derivative, some coefficients. So what are we going to do? We're going to take that inspiration that y has to be based on e to the 2t. That's the only way to get this left-hand side when it simplifies down to give us e to the 2t. But it could be any multiple of it. And so what we're going to do is guess that y equals, we're going to typically use capital letters here, e to the 2t, where a is a coefficient. No kidding, it's a multiplier. And it is undetermined. We don't know what it is yet, but we're about to determine it. The key thing in this process, though, is that our right-hand side is what dictates what our guess, our inspired, our informed guess, but still a guess, at the form of y is. And notice this would be our non-homogeneous part of the solution. So we're going to guess that our non-homogeneous solution looks like e to the 2t, possibly with a multiplier out front. How do we find the only thing we don't know, which is that a? Well, we're going to sub it into our differential equation. We're going to sub our y equals nh into the dE. Well, for that, we're going to need, we're simply going to call it y here. From here on in, we're going to need y prime. Well, that's going to be 2a e to the 2t, and y double prime is going to equal, get another 2, 4a e to the 2t. Go back to our differential equation, and we sub that in. We're going to have 4a e to the 2t, that's our y double prime, minus 3 times the first derivative, 2a e to the 2t's, that's our y prime, plus, minus 4y, which is just a e to the 2t. And what we expect is somehow these are going to cancel out and leave exactly what the equation told us we had to have it equal, which is 3 e to the 2t's. Well, this is fantastic. Every single term has an e to the 2t. It's never 0. We divide by it. And lo and behold, we get 4a minus 6a minus 4a equals 3. That's a nice linear equation just in a's. We have these cancel, and we get a is equal to 3 over minus 6, or negative 1/2. So y equals, and let's make sure this is the non-homogeneous part, or solution to the non-homogeneous version, is simply negative 1/2 e to the 2t's. Now we know that would work because we effectively subbed that in here, except with an unknown a, and we just sorted out what a was. And that's it. That is how we could solve for a part of the general solution, but the new part of the solution, the part that corresponds to having a right-hand side that's not 0. What if the right-hand side now was 2 sine of t? Well, again, what we have on the left-hand side is y's, y primes, and y double primes. Well, if I'm going to have y equals sine of t, then I better have some sines in there. But if my y has sines in it, my y prime is going to have coses in it. So keep that in mind. If I had y and sine, I would end up with cosines in y prime, but there aren't any on the right. So somehow I need to cancel that out. Well, what we could do to achieve that is put sines and coses in our y Then we get sines and coses in the y prime and sines and coses in y double prime. And if we chose them right, chose the coefficients correctly, they could all sort themselves out. So we just had the sines left and implicitly no coses left. So what we're doing is we're looking at this right-hand side and saying, okay, sine is one of the building blocks we're going to need in y. But what else could come out as we differentiate, because the other side has derivatives? Well, we're going to get coses popping out. Do we need anything else? Well, no, because if we have the derivative of cosine, we're just back to sines, or some multiple of sines. And those are really the only two building blocks we're going to need, going back to that idea of linearly independent sets and bases. If I have sine and cosine in y, I can surely make it work out so that y and its derivatives combined will give us a sine and 0 coses. Let's see that play out in practice. Our guess is going to be that our non-homogeneous part is going to be some combination of the sine, and notice it's just sine of t. This has been 3t, I would put 3t here, but we also are going to potentially need cosines so that the cosine terms in the derivative cancel out. To be able to sub that in, we need to take the derivative. So we'll take the derivative, we'll have a cos, and derivative of cosine is negative, so we'll have negative b sine. And also the second derivative, which is in our equation, we need that as well. We're going to get negative a sine of t minus b cos of t. Now we're going to sub that into our differential equation, and that will hopefully let us solve for the undetermined coefficients, which are a and b. Let's see how that plays out. Y double prime, second derivative, negative a sine of t, negative b cos of t. That is our y double prime. We also have negative 3 times y prime. That's the a cos minus b sine. And our negative 4y, our y is a sine b cos. And that all has to add up to 2 sine t. This being our y value. And that's it. We have to add one extra thing here if we want to make things explicit. There are 0 cos of t's. But what we can do is, if these are going to be equal, we have to group the like functions. And let's do that here. We'd have negative a all times sine of t, let's say. Sine of t has a negative a minus 3 times minus b is plus 3b's, our minus 4a for this. Plus we're going to have some cosines. And we have negative b of them here. We have negative 3a here. And we have negative 4b here. That has to equal 2 sines and 0 cosines. Well, because of linear independence, we won't go through the theory here again, but we have essentially vectors or bases with sine t, cos t on both sides. The only way these can be equal is if the coefficients are going to be equal to each other. And so the coefficients must be equal for sine and cos, then we get a nice pair of equations in this case. One for the sines, one for the cosine coefficients. So let's simplify this. We have minus a and minus 4a is minus 5a plus 3b's equals the sine coefficient, which was 2. And we also have minus 5b's and minus 3a's equals the cosine coefficient, which was 0. And that is a nice system of linear equations with just 2 variables, 2 unknowns. We should be able to solve that. We'll do that on the next page. Once we have these 2 linear equations, we can solve them any way we like. I prefer usually just to multiply and add the equations. So if we multiply this by 3, we'll get negative 15s. And if we multiply this by -5, we'll get positive 15s. And so we'll add those guys together. That'll give us 0 A's. We'll have 9 B's plus -5 times -5 is 25 B's, equaling 3 times 2 is 6. And that will give us 34 B's equals 6, or B equals 6 over 34, or 3/17. So that's one variable down. And we can then solve for A. Minus 5A, pick either equation, is going to be 2 minus 3B's. That's going to be, A is going to be -1/5 times 2 minus 3, 3 over 17. And with a bit of calculator work, that gives us -5 over 17 as our A value. And so, a solution to the non-homogeneous differential equation is A, let's go back and make sure we know what that went with. A was a coefficient of, go back to the top, this was our definition of our solution. The A went with a sine, the B went with the cos. So -5 over 17 sine of t plus 3 over 17 times cos of t is a solution to our differential equation y double prime minus 3y prime minus 4y equals 2 sine of t. Seeing it in this form, you can imagine how it would play out if we keep differentiating this to get y prime and y double prime and subbing it in. There's going to be a cosine in every term. They end up canceling out perfectly. That's why we set up our equations and we got the solutions that we did. But the sines won't cancel out. In fact, we'll end up with 2 sine t's left over once we simplify those 3 terms and their mixture.